See, in the last class we were discussing about that geometric image transformation, okay? And I will first browse little from the last class, so that you can recollect what I was discussing, that geometric image transformation is required because of there is certain distortion you will find in your image. Now, distortion may occur due to several reasons. One is maybe the distance between the subject or object and the camera may not be fixed, because why I need to compare the two images, or I need to understand the correct picture. I want to see the correct picture. So, in the case of say satellite image, I need to correct it because of earth is rotating, earth curvature is there. So, those corrections I need to make it so that you can visualize the thing. Same is the case with the biometrics also. Once I take the picture, I need two pictures I need to compare. So, I need to know whether the photographs are taken from the same distance or not. If not, then I need to do little modification, so that it looks like that it is similar, it is at the same distance, right. And besides that, there are other types of distortions are there. Say for example, that sensor is not performing well. What is the guarantee that some of the, suppose I have the several CCD lights to capture your data, and you cannot imagine that, or cannot think that intensity of each sensor or each CCD is same. So, some if you have the several tube lights, some of the tube lights after time t you may find that it is not giving full illuminated illuminations, some of them are giving the due illumination. So, the area which you have the affected area, you need to do certain operations to get it equivalent illuminated area, right. Same is the case with that, there may be some noise, or there may be some CCD lights are not giving the, it is not working at all. So, you need to do certain corrections on it. So, generally this transformation is required to match the two images you have obtained after different time instance, right. Because if it is the same instance, same type, same distance, everything is same, what for you are comparing, you got the image. Now, that transformation is nothing but that you want to have that xy, image is represented by xy coordinate system. So, you want to impose some transformation in xy to get the new coordinate system, which is x dash and y dash, right. Now, this transformation vector is dependent on few things. First one, that it may be like that, a priori the distance between subject and the camera is 1 meter, another one is 3 meters, that is known to you, or a priori that it is rotated by theta degree, right, or that because of some reason, the knowledge is given to you. Another one is that no, I have the two image, as in the case of biometrics, I have the two image, I need to compare. And another thing, that I know a priori the two image, and so these two image I want to superimpose, so that you can compare. So, this is that for a given image, suppose this is your original image and this is the another image you want to compare. So, you need to do some operation to map in such a way that it becomes comparable. So, these two informations are given to you, these two images are given to you to convert one into another one. Now, generally it is assumed, or it is also you can think that it is acceptable to you also, that whatever transformation matrix you are using or vector you are using, function you are using, that will be true for throughout the image, right. Suppose I am rotating this point by theta degree, the next neighboring one also will be rotating by theta degree, right. So, that is because whatever operations you will be, or whatever transformation you are looking for some pixels, that should be true for all other pixels. Second is that generally it is assumed that distortion is within few neighboring pixels. For a particular pixels, distillation should not be a very difficult one, very complicated one. So, generally we assume that it is of the type polynomial of degree n, but this polynomial of degree n we assume that not more than 3, right, because you can think that degree k, but problem is that as you are increasing the degree k, you have to estimate k plus 1 coefficient for x dash and k plus 1 coefficient for b dash or y dash. Okay. So, more complex you are, more computational time you are considering. So, generally it is sufficient, or we feel that degree 2 or degree 3 is sufficient. Now, once I consider the degree 2 or degree 3, degree 2 means basically I need the 6, 3 for x a0, a1, a2 and 3 for y, that is b0, b1, b2. So, you need to obtain that x dash and y dash for x simple degree 2, you need the a0, you need to compute this one, right. That means you need one variable here x1, x2 and x3, agreed, to get corresponding x1 dash, x2 dash and x3 dash. If I know these 3 values, I can compute these values by least square fitting, right, yes or no. So, that is along the x direction. Similarly, is the case with the y directions. If I need to compute of degree 2 polynomial and x direction and y direction separately, then I need that another 3 pairs with respect to y, b0, b1, b2, then you can compute. Now, you remember what I am doing here, that I am considering x1, x1 dash, x2 corresponding value is y2 dash and x2 dash and x3 and corresponding value is x3 dash to compute a2, a0, a1, a2. Now, the grid, if I consider this is a grid, you remember that this value is not only dependent on this one, it should be dependent on this one and this one also, because it is not guaranteed, right, that x and y are independent, right, the impact may be there. So, there is another way is that we can think about the bilinear interpolation, right, bilinear values, bilinear transformation. So, it is a0, a1 x, a2 y plus a1, a3 xy. So, here it is a 4 value constants a0, a1, a2, a3 and b0, b1, b2, b3 for y. So, corresponding you need 4 such equations. So, basically 4 x1 values and x1 and 4 y values you need to estimate x dash and y dash. So, that is why it is 4 pairs of corresponding values is required. Now, similarly is the affine transformation, where it is a only you are considering the a0, a1, a2, a0, a1 x plus a2 y, because this is only it is considering. So, to estimate this you are taking only these values, this value and these values, right. So, that is the thing it is considering, they are only linear things, nothing simple equation, not the interrelationship between x and y and so on. And this takes care of rotation, translation and scaling and skewing. What is rotation? That it is, if I want to rotate the image by theta degree. What is translation? That I want to move the, because you know the photograph may be this one and the same photograph may be little up. So, you need to move up. So, that is translation. What is scaling? That I want to zoom it or zoom out and so on. And finally, skewing means I need to slant the image by theta degree, right. This is an image, I want to slant it by theta degree, nothing else. Now, this also I told that it is creating geometric transformation creates a new system or new coordinate system, and Jacobian gives you the information about the how that coordinate system changes. So, it is nothing but the derivative j, whatever transformation function you are taking, your derivative with respect to x and with respect to y, partial derivative, and then you take the determinant of that. So, if the transformation is singular, that is no inverse, nothing is, then j will get 0, and if j is equals to 1, that means that this whatever system or transformation you are whatever system you are making, that area of the image is invariant under that transformation. So, I want that it is rotational invariant, that means j must be 1. It is invariant to scaling, then j must be 1, that is the idea. Now, bilinear j value will be coming like this, and for affine transformation the j value will be coming that a 1 b 2 minus a 2 b 1. So, this is a standard the formula of rotation, right, that I want to convert polar to Cartesian, same idea here, and j is, if you take the derivative of this, and the j will find 1. For the scale it is also a b, and so it is, you cannot tell it is invariant to this perfectly, because it is dependent on the value of a and b, and translation and skewing by theta angle. Now, what happens that you got from one coordinate system to another coordinate system, this is the first step. Now, once you got the new coordinate system, you have to put the intensity value on that coordinate system. So, that brightness to be interpolated. So, what happens? I have this intensity value, and I got a new coordinate system. For this value, I got x dash and y dash. For this x y, you got x dash and y dash. Now, this x y is this is integer, but this is not guaranteed that this will be integer. This will be a real, right? Because you have obtained, say, in the case of rotation, it was x cos theta plus y sin theta, something like that, right? You will get some real number. So, for this real number, what is the intensity value you have to find out? And this is true for the whole image. That is the problem. So, as I am telling that it is not necessarily that it will be on the integer platform, the values will be coordinate into non-integer. So, you need to obtain the values of the integer, because your output image is also a grid, and you got the value of x dash y dash here, but this is not useful to me. I need to know the intensity value for these elements. I need to get the intensity value for these integer values, not these intermediate ones, right? And this interpolation, whatever interpolation, because you will be taking the help of the neighboring ones to determine the intensity value. So, intensity value of each coordinate points. So, this interpolation technique should be very, very useful, because very powerful things, that you should consider such an interpolation formula, so that the quality maintains. Now, if you take this very simple interpolation formula, the quality will be degraded. But if you take the very complicated one, the Lagrange's interpolation formula, you will get the very good quality image, but the complexity will be increasing. So, there exists a trade-off relationship between the quality and the computational time. So, simpler is the interpolation formula, you are losing the information more. The three well known in brightness interpolation technique or intensity interpolation technique, they are, one is the nearest neighbor, next one is the linear, and third one is the bicubic, right. Now, as you know that we have to compute the intensity value of the output image from the input image, right. Now, you got a transformation matrix or a vector through which you got x dash or y dash. Unfortunately, they are in real domain. So, you obtaining the intensity value for the output image will be little difficult if I follow that path. Instead of doing that, I get this is my output image. For each coordinate in the input image, what is my x dash and y dash? Can I find out? Just inverse transformation. I know now A0, A1, A2, A3, whatever coefficients of the equations. Now, if I know A0, A1, so I have x dash equals to A0 plus A1 x plus A2 y plus A3 xy. I know these values. So, I know also x dash and y dash, x dash and y dash. I can obtain what is the value of x in my original input image. Yes. So, that will be in the real domain. So, if I know the intensity value of that real domain, I can find out what is the intensity value of that. Yes or no? Agreed? So, I have this to be the in my input original, this is output 1, this is input 1, output this one, suppose this maps to this one. I have to estimate the intensity value of this, which can be mapped here. Agreed? Now, how to do this? That is the problem now. Now, the problem is simpler. Problem, what is the problem? Problem is that I have an input image and I am here, this has come from some grid of output image. From this one has been mapped here. Now, I have to estimate the intensity value of this, which can be put here. And that is, there are three ways what we like to make. One is nearest neighbor, another one is linear, and third one is the bicubic. So, this is to get the Biometrics value of the point, the input image is resampled. This is known as resampling. Now, in the case of nearest neighbor, idea is very simple. See, I have x dash here and I have y dash. I take the round of x dash, I take round of y dash. Suppose this is capital X and this is capital Y. So, I can put this intensity value is nothing but I of, this is the input image, this is output image, I of capital X, capital Y. Right? Round of x dash, suppose it is 4.7 and x dash is 4.7 and y dash is 7.9. So, round x is 5 and y is 8. So, I find out what is the intensity value of I58, that I will be putting here. Is it okay? Clear? So, how much error I am making? Half pixel, not more than that. It was 3.5 and I have made it 4. Right? If it was 4.5 another side, I have made it 5. So, maximum error is half pixel. Right? But in reality, suppose a pixel represent 1 meter by 1 meter, then basically error will be 0.5 meter cross 5.5 meter, 0.5 meter x direction, 0.5 meter in y direction. That is the error, right? But method is very simple, but it creates little problem. That is, since you are making it the nearest neighbor approach, you are not, there is a chance that step like boundary problem will be there, because why step like? Because this will be mapped to this, and there may suppose this is mapped to this, and this one also will map to this, right. So, one is positive 5 pixel, another one is negative 0.5 pixel shift will be. So, there is a chance of like this movement, error will be there. So, error is 0.5 pixels in x direction and y direction, and there is a possibility of step like boundary problems, right. This is only because of taking the rounding factor. Now, the second one is that linear interpolation, which is more powerful than the nearest one, because here he is not only considering that this round of this word, he is considering these 4 pixels information, this 4 pixel informations, and he wants to give the weightage on all these 4 elements, right. So, let us assume this is A00, this is known as A01, this is A10, and this is A11. These are the 4 coefficients. I am writing A00 plus A10x plus A01y plus A11xy, right. So, this if I start thinking little different way, then what happens? This is your points to be estimated, and say let us assume this is A is x minus x dash minus that, and B is y dash minus y dash. So, integer, so I get the leftover part, that if I x dash minus x bar is what, that whatever 0.5, 0.3, 0.7, that number will be coming. Similarly, y dash minus the lowest integer, largest integer smaller than y dash. So, you get B. So, I give the weightage on these elements as 1 minus A and 1 minus B. Here it is 1 minus A and B, and so on. Similarly, here A 1 minus B, and here it is AB. So, that is the thing of some weight I am giving, because I have to give the weight to each vector. So, depending upon the distance from the coordinate system, we are putting that weight. So, this is nothing but 1 minus A, 1 minus B, and intensity value of this one into, here I have written A, and here it is 1 minus B. Yes. Oh no, it was correct. Then A into 1 minus B, intensity value of this, plus this into intensity value of this, and also same way you have written this. So, this is very simple, just you put it and you will be getting the intensity value of these points. That will be mapped to my output image. Agreed? Is it clear? But in that process, since I am giving the weightage of all the 4 neighbors, so that stepwise boundary effect will be minimum. It will need not be 0, but it will be as minimum as possible. So, but at the same time, suppose I use A equals to half and B is equals to half, that will be exactly center. That is nothing but that averaging of the 4 points, 4 intensity value, and you are putting it, right. If A equals to half, B equals to half, then it is nothing but the 4 points intensity value, and you are averaging it, and you are putting it. Now, once I am giving the average of the 4 numbers, what will happen? The resolution will come down, yes or no? Suppose I have any 4 numbers you take, 3, say this is 4 and this is say 8 and this is 10 and for simplicity this is 6. What is the value? 6 and 18, 6 and 18 is 24. So, this will be what? Divided by 4, 6. So, the number that for this points it is 6 it will come because I am telling that this is half say. So, this will become 6. Now, the resolution say it may be it should have been the 10 or should have been the nearer to 2 and 4, right. But because of this that intense resolution will come down because you are making near averaging technique, and once resolution comes down. So, what will happen to my output image? That resolution will be coming down overall because for each point resolution will be down. So, it will be having little dull image, right, agreed. Now, once it is dull image and so image is dull means there will be blurring effect, right, but image will be smooth, there is no ambiguity, that image will be smooth, looking smooth, but it is a dull image and blurring effect will be there. But of course, the step like boundary problem will be minimized. So, what I did here? I have taken the four neighboring points to estimate the intensity value of x dash and y dash. Now, what happens to the bicubic technique? The bicubic technique, you are considering for this point, I will be considering this point, this point, this point, these points. These 16 points, right, this 16 points. And same idea we have used for bicubic also, that I have given A0 this weights, corresponding weights, and then you get the value. Now, obviously, since linear interpolation is reducing the step like boundary problems, the cubic equation also obviously it will be reducing further. There is no ambiguity. Now, the blurring effect on the linear interpolation, because of only 4 points you are taking, it was making the dull. Now, suppose let us consider another example 3, 4, 5, 6, 3, 3, 4, 5, 6, 7, 8, some number. So, this is the point is there. Now, if you obtain, suppose let us assume that it is also, I am not using the, because I have to compute otherwise that cube, let us assume that I am just adding them and divided by 16. That is also average, right. But if you observe, this average will be better than the more points. So, properties of more neighboring points you have taken into account, and you are trying to fit a degree by cubic degree you are trying to fit on it. So, obviously, you will be getting the much more better intensity, because you are taking the information of more number of neighboring points, right. So, this is all about the geometric image transformation. What I have done here, that given one image and you want to compare with another image, you need to transform one of them so that you can compare, right. So, first step is that you have to use some method to convert one coordinate system to another coordinate system. Once you have defined that coordinate system, now you have the one input coordinate system, another is the output coordinate system. from the output coordinate system, you try to map into the input coordinate system and use one of the three methods to get the intensity value of the output coordinate systems. That is the strategy. This is what we have done, that after transformation, geometric transformation, you are changing the intensity value. The another problem you will be finding, that I have one image, but you need to do some operation on it. For example, that you have launched one satellite and you are supposed to get the intensity level 0 to 255. You are supposed to get, because that is the plan, but unfortunately it is giving the data which is lying between say 17 to 32. Intensity values are lying between 70 to 32. Now, if 70, that will not be much useful, because it is a very poor quality image, nobody will understand, right. So, what you have to do, you need to improve the intensity, right, to enlarge the intensity, so that people can visualize it is lying between 0 to 55. So, there is no question of geometric transformation, this is a question of radiometric corrections, that you need to do some corrections, so that it automatically looks better. So, it is pixel by pixel. So, it modifies the pixel intensity. So, it takes the help of that pixel only, it does not consider the other pixels information. Now, there are two types of pixel brightness transformation. One is the brightness correction, as I told you that only I want to transform from one to another one, nothing else. Another one is the grayscale transformation, right. Now, in the case of brightness transform corrections, it takes the pixel intensity into account, and also it takes the position of the pixel. Why it happens? Why it is required? For as I told you, that some of the all lights are not giving you the equally illumination things. Some of them you may find is not doing the things. So, what happens there, that for that area you need to do some corrections, right. So, the position of the pixel is important, not only that intensity of the pixel you want to improve, and you have to also find out the position of the pixel, for that you want to improve it. In the case of grayscale transformation, it modifies the pixels without understanding its positions. It is not required, only it modifies the intensity, but it does not need to know the position of the pixels. So, ideal situation is what? That whatever device you have, right, and through that device whatever image you are getting, that image should not be dependent on the position, right. Any pixel, I will assume that every pixel will give me the good results, that is the ideal situation. But as I told you an example, that light sensors may create the problem for you. Another one is that illumination effect is also creates problem, right. Say for example, that the background of the image is something different. So, neighboring area, this area will be reflected more, frontal area may not be reflected much. So, this systematic degradation can be suppressed by the brightness corrections. Suppose I know that Eij is the error to be corrected at the ijth pixel, and I know that image Gij is the original image, that it should look like this, ijth pixel is Gij, and but you are getting the image Fij, ijth elements intensity is Fij. So, Fij is the Eij into Gij, right. Now, this Eij you have to estimate. So, you take one original picture and you take the output picture, you can find out what is Eij. Once you know this Eij, that has to be calibrated every time whenever you take the photographs, and but you have to estimate, because you know that light sensor also performing degradation will be there continuously. So, calibration has to be done at a regular interval. So, EIJ need not be fixed throughout your lifespan, right. The other one is the grayscale transformation. As I told you that it is not dependent on the position of the pixel, but what happens sometimes I like to see the negation of my image. What it means? That whatever pixel value I have, that white I want to convert into the black, black I want to convert into white, right. So, if I draw this graph, that all the 0 intensity value, I want to put the highest intensity value, all high intensity value, I want to put the low intensity value. So, for each pixels, I change the intensity level by some method, right, and that can be done using the simple lookup table. The 0 maps to 255, 1 maps to 244, 2 maps to 253. So, as soon as I get a 1 intensity value, I just replace it by that lookup table. Agreed? Similarly, the case that I want that this intensity area, I want to make it 0. I want to make it dark, and remaining I want to make it white. So, all the pixel values, all the pixel intensity value more than this, they are all white, and I can put, then I will be getting my intensity chart is like that. Or I sometimes what I want that all the pixel having the intensity value lying between P1 and P2, I want to put this curve, otherwise I want to put this way. It is possible, right. So, this will give depending on the situation. Sometimes I like to give the importance only on the snow area. You got a photograph where snow is there, I want to give the importance on the snow area. So, the snow may not be always white, sometimes you may get it because of sunlight, you may get the yellowish color also. So, you need to convert them also into the snow, and you may, so you will be able to make them the 254 or 255, and you get the snow area, right. And other part I can suppress it, I do not want to see it, I make it 0. So, simple lookup table can be used to make this transformation. Now, next picture is histogram. Now, you know what is histogram, right. Histogram is gives you the information about the frequency of occurrences. Agreed. So, same idea here, you have the 2-dimensional image, and the image contains the pixel values or intensity values of each pixel. These pixel values will be lying between the minimum intensity level and maximum intensity level. Ideal case it is 0 to 255, but in reality it will be lying between say some number P1 and P2. So, I can have the frequencies of the intensity value P1 is this much, then frequency of occurrence of intensity value P1 plus 1 is this much, and so on, right. And that sum of this frequency is the total number of pixels. Agreed. So, I can have the histogram from the image. This histogram is very powerful. Suppose there is only one peak or only one level, only one. That means, all the elements in the image is having this value, right. So, no information you will get from that image. So, you will be telling that it is a featureless image. Agreed. So, if there is only one beam, then you tell that image is featureless. by seeing the image or histogram, you can tell always what is the intensity level or what is the maximum intensity and the minimum intensity of the image. Am I right? Because you will be knowing this is the minimum intensity level and this is the maximum intensity level. So, range of the intensity levels is known to you, right. And once you know the range of the intensity level, you will be able to think that whether there is a need to change the intensity level. Suppose I have one image where intensity level is lying between 55 and 75, and another image of the same object or subject is lying between say 15 to 200. So, in order to compare these two, you will like to convert either 15 to 200 to that previous size intensity level or previous one you want to try to convert, so that it looks alike, right. So, in order to do that, you need to perform one technique which is known as contrast enhancement technique or histogram stretching technique. And now, if I want to put in some hidden information on my image, I cannot put the hidden information on my original image, right, foreground image, because which is keeping say your photograph and there is a background. Then, now, if I put some information on your photograph, then you will feel that yes, I have spoiled your photographs. So, the information I like to put, that I will be always liking to put it in the background area. So, these people who work in the field of steganography, they have to analyze which area he wants to put the data, so that the original data does not get distorted. Original image should not be distorted, right? Otherwise, people may not like to see that image. At the same time, you want to send some information through this image. So, this background or information is very useful for several purposes, but not for mainly for biometrics. Now, we use the word contrast of an image, right? We tell that what is the contrast. So, contrast of image depends on the contrast of each pixel. Now, what is the contrast of a pixel? Contrast of a pixel is nothing but the image intensity at that pixel minus average intensity divided by the maximum intensity minus minimum. That's why I am dividing, that is the normalizing the factor, nothing but that, right? 1 minus or 1 by I max minus I min. Now, this histogram we need to transform very frequently, right? As I told you that I have an intensity level lying between A and B, I want to get to C to D. How to do it? So, there are 3 ways you can do it. One problem is histogram expansion, that is output histogram specified, and finally you have histogram transformation specified. What is histogram expansion? This is a very simplest one. Then I have one histogram lying between this range P1 and P2. I want the histogram should not be this, I want histogram should be 0 to 255. So, this has to be expanded in that order, so it becomes the range is lying between the minimum intensity level will be lying between minimum maximum lying between 0 and 255. Is it clear?
Why would we perform this on an image?
Why we need? Suppose I have an image whose intensity is lying between 35 and 75, right? Even though I have the power to have this 0 to 255. So, 35 to 75 if I have, that image will be very dark color, right? And once dark color, visibility will go down, right? But if I distribute it in the larger intensity level, then you will be able to see the edges properly. You will be able to see the minor points that which are missing in 0 to 35 to 75 that may be visible for you. Image look wise will come out better way. You can do certain operations like edge detection properly and other things. Is it okay? So how to do it? So min-max is the best method to stretch it. Linearly I will be stretching it. That means that the smaller P1 value will be mapping to 0 and P2 value will be mapping to 255. Agreed? So how to do it? That I just linearly I am stretching it. This linear stretching formula is simple. Linear equation x minus x min multiplied by y max minus y min divided by x max minus x min. The linear equation I am just fitting it to expand it.
Sir, is this the same as histogram stretching or contrast enhancement?
Yes. This is still stretching on. So, in the case of I want to expand it 0 to 255, then y max becomes 255 and y min becomes 0. Right? So sometimes I decide, see the previous one can be done automatically, right? I give the input of the image, I automatically find out what is the minimum intensity level, what is the maximum intensity level, and then automatically I can find out the stretched one. No intervention is required. Agreed? Now here also, output, what should be the histogram output? That I want to do. So sometimes I may not like to stretch it equally. I want to give some importance to the lower intensity level, not the higher one. Sometimes I want to give the importance to the higher intensity level, not the lower one, and so on. So for a positive slope, the range occupied being in the lower intensity level is stretched. So what should be the lower? That depends upon your thinking or applications problem. That I want to study the snow thing, then white higher intensity level only you want to discuss. If I want to see the dark area, then the lower intensity. And since I know a priori the stretching level, that is I want to stretch only the lower intensity level, so this also can be done automatically. No manual intervention is required. Sometimes, I don't know, okay. Now this is useful to compare. This transformation is also useful to compare the two images